Hello friends, welcome back to Rising Mathematics. In this video, I am going to solve exercise question from book Topics in Algebra from chapter 3, Ring Theory. Question is, if A is some element from ring R, let the set Ra is set of all those elements of the type Xa for element X from ring R. Prove that the set Ra is a left ideal of ring R. Firstly, we will see the meaning of left ideal of ring R. So, if R is any ring, a subset L of ring R is called a left ideal of R if number 1, L is a subgroup of R under addition, and number 2, for element R in ring R and for element A in L, we have Ra is an element from set L. So proof, here R is a ring and Ra is this set. Now consider any two elements, say R1 and R2 from the set Ra. Therefore, R1 will be equal to x1a and R2 will be equal to x2a for some elements x1 and x2 in ring R. Then we have R1 minus R2 is equal to x1a minus x2a, which is equal to x1 minus x2a, which is equal to x3a, where this x3 is equal to x1 minus x2, an element of ring R. So we get R1 minus R2 is some element of ring R dot A, and therefore R1 minus R2 is a member of the set Ra, and thus Ra is a subgroup of R under addition. Now number 2, consider an element say R1 from the set Ra. So R1 will be equal to x1a, where x1 is element from ring R and some element R from ring R. Then we have R dot R1 is equal to R dot x1a, which is equal to R dot x1a, and which can be written as Ya, where this Y is Rx1, which is an element of ring R. So here R dot R1 is an element of the type Ya, where Y is some element of ring R, and therefore R dot R1 is an element of the set Ra. Therefore, from 1 and 2 we have the set Ra is a left ideal of ring R, and this proves our result.